So we'll start today's session with a new topic, precedence of logical operators. Okay. So let's understand before we formally see what is the precedence of this logical operators. Let's understand why do we require this? Why this precedence is important with respect to logical operators. So let's consider this particular compound proposition. So as you can see, there are three operators here. The first operator is nothing but negation. The second operator is this conjunction, and the third operator is nothing but implication. So now, since there are three operators, we should have some priority rules. Otherwise, what will happen? If we don't have this kind of rules, then there are several ways to evaluate this particular compound proposition. For example, what you can do, you can give importance to this segment first, and then you can consider the so first you will evaluate this particular conjunction, and then you whatever you get is, let's say, S, and then you talk about S implies negation P, right? So you are giving importance to conjunction over implication. So this is one possible way. Another possible way is, it may possible that you give more importance to implication as compared to this conjunction. In that particular case, you will evaluate this first, right? P implies negation P. You will evaluate this first, and then you will evaluate, let's say, the result of this P implies negation P is S, and then you will be evaluating negation Q and S, right? So that means if we don't have proper precedence rules, then for the same compound proposition, it may possible that your answer differs. For example, let's say I give this kind of truth values. Let's say P is equal to true and Q is equal to false, right? And it may possible that in some of the interpretation, this particular assignment gives us true value, whereas in some other interpretation, it is giving us, let's say, false value. So that means it's not consistent, right? So therefore, we must have some rules using which we can simplify the given compound propositions by applying this priority rules. Okay, so now let's understand which are these rules. So basically what we need to do, we need to consider this particular table only, right? So this table is saying that give highest precedence or highest importance to this negation. Okay, so and it makes sense also. Why? Because if we try to relate this with our traditional number theory, then often, let's say, if I give you to multiply -3 with 5, then definitely you will first consider this minus sign. This minus is nothing but unary operator, right? In this particular case, and then you perform this multiplication, right? So definitely we are giving more importance to this kind of unary operator. So similarly here also we are going to give the highest importance or highest precedence to this negation operator. Okay, the next importance is, or next precedence level is for conjunction operator. So conjunction is you can say it's equivalent to our multiplication, right? So after unary we focus on multiplication. Then we talk about disjunction. So disjunction is, so this is similar to multiplication, this is similar to addition, right? So after multiplication we give precedence to disjunction, and then we give precedence or importance to implication, and finally we give importance to biconditional operator. Okay, so that means negation has the highest precedence, biconditional has the lowest precedence. So if we follow these rules, so then what will happen with respect to this particular compound proposition? Negation Q and P implies negation P. Let's say this is my compound proposition, and there are three operators, as we can see. right? So by default, this will have higher precedence. Okay. So depending upon values of P and Q, first we will evaluate them. Then what we need to do? Then we need to compare these two, conjunction and implication. So between conjunction and implication, right? So I am talking about remaining two operators, which are nothing but these two. This conjunction and implication. In these two, the winner is conjunction. So that means what you need to do? You need to put brackets like this. First, you are giving importance to this conjunction operator, right? And then whatever result you get, let's say you are getting result R, that you need to apply with this implication operator, right? So if I simplify this particular compound expression with respect to precedence rules, then I can put brackets like this. First bracket will be for this negation Q and P. The second bracket will be for this entire proposition now, right? So what is the meaning of this now? So this, the initial proposition was like this: negation Q and P and negation P. So here precedence rules are not clear, but by putting this brackets, now we have just made it clear that give more importance to this conjunction and then perform this implication over the simplification of this conjunction, right? So that is the idea of this uh, precedence. So now let's consider how this will be useful in the case where we are trying to, let's say, design two tables. So let me give you one proposition, one compound proposition, and let's say what we want to do, we want to write down truth table for this particular proposition. So let's say the proposition is like this. So I've already used symbols P and Q, so let me use R. So R implies negation R and negation S, let's say, double implies S. So now, without knowing about precedence rules, this seems very complicated. So the traditional approach is one can consider it like this: first, evaluate R implies negation R, then evaluate negation S double implies S, and then use nothing but conjunction between them, right? And that is your nothing but final answer. But here we haven't considered precedence rules correctly, right? We are just going by our intuition, right? So this is wrong. So what we need to do, if this kind of proposition, compound proposition is given, where you are supposed to identify what is the precedence, then first you need to identify which operators you need to consider. The first operator is negation, negation R as well as negation S. So we are going to evaluate them. So what we can do, in the two tables, straight away we can say R and S are there, but along with R and S, there will be negation R, there will be negation S, because they are involved and they will be having higher precedence. So that's why we are doing this. Now the remaining operators are three. Which three? First one is implication, the second one is conjunction, and the last one is nothing but biconditional or by implication. So now we know among these three, the highest precedence is for conjunction, right? So what we need to do, we must evaluate this particular thing first, negation R and negation S. So after evaluating negation R and negation S, what we are going to do in the next line, negation R and negation S. Okay, so let's say this is my new proposition, let's say T. Okay, so I will be evaluating T now. Okay, once it is done, now I have a competition between these two, implication and double implication. So we know that between implication and double implication, the winner is implication. So therefore, what we are going to do, we are going to evaluate R implies T now, right? So the brackets are going like this now. Next bracket will come between R implies and then here, right? So the next thing which we must consider is R implies T. Okay. Now R implies T is done. So now we don't have any other choice. Let's say this R implies T is nothing but, let's say, U. So I have remaining thing is U double implies S, that is to be evaluated finally, because now this is the only operator and hence it has the highest precedence, we can say. And finally we'll talk about U double implies S. So let's say this is my U now, and I will talking about U double implies S. Okay, so now we can complete this particular truth table. And for these four combinations, the first operator which we are going to consider is negation. So negation R and negation S. So we can directly say this is F, these two are true. Similarly here, this is F, this is true, this is F, this is true, right? Now we are giving next priority to conjunction. So conjunction of this two, right? So false and false is false, false and true is also false, true and false is false, and finally true and true is nothing but true. So we are done with evaluation of T. So that means this bracket is completed now. Okay, this is done. Next we need to consider R implies T, because now we are giving importance to, so this first part is done, the second part is this R implies T. Okay, because implication has higher precedence over double implication. So R implies T, so that means I need to focus on this first column and this fifth column. Okay, so only case which I need to consider is TF. If TF is there, then my answer will be false, otherwise my answer will be true. So for first two entries, TF is there, so therefore my answer is false, and for remaining two cases my hypothesis is false, so I won't care about my conclusion, straight away I will write down true, right? So I'm done with calculation of U, right? So U is calculated, part 2 is also done. So now the last part is remaining, which is nothing but U double implies S. So now I need to focus on the column number 2 and column number 6, correct? And what I need to check, if entries are same, both true or both false, then I will write down true. So therefore I am writing down true here because of this true and this true things. Okay, so here we will write down true because both are false. S is false and U is also false. And last one, FT. So we'll write down F here. Okay, so our truth table is done. So what is the motivation here? If we don't know this precedence rules, then it may possible that we end up with calculating the wrong proposition, wrong compound proposition, which is not the equivalent proposition for the given proposition, right? So that means we are calculating something else which is not required for the given question. That can happen if we don't follow these rules.